think on the algebra thing is like this. I think we should just.
Oh, for me too.
Yeah, the number gives, that's it.
That's all of them.
Do we have to?
Oh, that was the
Yes.
pictorial I was thinking. So that was the pictorial I was thinking.
Yeah. So yeah, you will need to, you will need to kind of explain just like your pictorial and then how you use that to get to the answer. You will have to explain it. And then, so one of y'all should definitely start writing the algebraic way y'all solved it though.
You see it solve it.
So,
I wrote it. That is. I
You
should
need to
probably
show the
erase
work.
it.
yeah.
You gotta show the work of how you got to, because that was a good start, but I want you to show us how you then got to the final answer.
So.
Two-dimensional cube.
Yeah.
It's
So,
something.
I do wanna ask what this one looks like.
Oh, one was 300.
Oh,
This
I
was
see.
300, yeah. I didn't even notice that.
Sorry, you said the thing, bro.
My handwriting sucks.
That's okay.
It's
As long as you can explain it, it's fine. I can read it. So now what should the next step be for solving for x? Excuse me.
Excuse me. This
When they-
try 300.
Yeah.
Yeah.
Sorry.
300. And minus 300 over here. And that gives us 2x is equal to 15.
Okay. Now, Linnea, what should our next step be here?
Divide by 2x.
So we get divide by all
Or
2x or
divide by 2.
divide by 2, right? You wanna, if cancels those 2, just create that 1, and then just have the x left.
So that cancels these out, and that brings us down to 7.
Correct.
Oh, that does. So x is equal to 7.
Okay, so now if x was 7.5, what did that make the bottom? Good. And we found that by, we found that by doing this, right? Okay, so let's write that out. So you can just do it right under.
Just write how much the bottle will be. Which was,
307.9.
As long as you can explain kind of how we got that for a second.
can I just use b as pretty much the bottle?
Yeah.
Was, what's the number?
307.5.
Oh, they have a softball
So now work on, right number 2. This looks good.
Now they have a softball game, Miss Kenny?
I don't know.
So let's, while they're still writing, how about this group start looking at number 3 real quick?
Already sure.
So you
Well,
try
I
number 3?
used to have Coach B last year.
Because this is something we'll do, this is kind of, our head a little bit, so let's just talk through problem 3 while they're looking at number 2.
70 animals in all.
Okay, 70 animals in all.
Then we need to do number.
Mhm.
Okay, 186 feet and then 70 heads. Okay. So, and I think, me and you talked about this a little bit, how many heads does
I
the
think
chicken
we should do that one.
One, okay, how many heads per cow?
And then we do.
So if there's 70 heads, how many cows and chickens does that make?
Which equation?
7. Okay, so let's say that, let's just make cows X.
Yeah, right. Nice large.
Let's make
number,
cows
but you're right, but
and then chickens Y. You already told me there's 70. Okay, now, now 186 feet, okay, so how many feet does a chicken have?
Equals
1, 2.
The chicken has 1 foot? That's not much, 2x. Okay, now how many feet does a cow have? 4. So each cow's gonna have 4 legs. And we had, you need to stop right now.
Yeah.
4y, so, and how many were there? 186, is that what it was? So now, so we're not gonna solve this right now, but how would, this is what we need to think about, how we can find what x and y are here, based on this system. First of all, do we see how we created that system, just kind of based on, that's how you kind of need to think through these problems. So then, once we look at this, we'll think about how we can solve for that. Does that make sense?
And then we went ahead and.
Yes, maybe.
I don't know how to solve
And that's something we can talk about, because I don't know how much we've talked about that, so that's something we'll talk about all together. Because that third problem is, it's a harder problem. Let's see how we're doing over here.
I think number two is number one.
Think so? Okay, so now, and so then for this one, y'all guessed and checked for the verbal, right?
Yeah.
So what y'all are gonna do is instead of writing all that, I'm just gonna have you explain how you found 16 verbally. Okay, so it looks like we both groups have finished. So I want Canty and McKay to start. So we can all let's just all stay around the board. So Canty, I want you to start by explaining your work on number 1. So it looks like it was written in that kind of red-ish color.
So, you get 2, so me and my kid did is 2C plus 300 equals 315, should be minus 300 both sides. Then you got 2C divided by 2 equals 15, or divided by 2. Then we did 2C plus 300 equals 315. Then you got C equals 7.5.
So this was your algebraic representation, correct? So that looks great. What I do want to ask is, so how did y'all get, and either of you can talk, how did y'all get the 2C plus 300 equals 315? How did you get that equation from the problem? You can look back at your work and look at the problem. Not sure? Any ideas?
No.
Okay, so let's throw it back to this group then, because I see, let's look at y'all's algebraic as well for number 1. So I see that y'all solved it basically the same way for algebraically as Canty did. So what did y'all think, how did y'all find that 2x plus 300 equals 315?
So x, we equaled x as the chord.
Okay,
So anyway, so the chord and both together both equal 315. So
okay, so you're saying the weight of the bottle and the cork combined with 315, right?
yeah.
So where did we get plus 300?
Because the bottle is 300.
It's 300 grams more
Yeah,
than
300
the
grams.
core.
Good, okay, so that's what I was trying to hit on. So we get 2x because we're looking at both the cork weight and the bottle weight, but then we added 300 because we knew that bottle weight was 300 more, and combined they were 315. Okay, so now let's compare. So this group over here, talk to me about your pictorial version of number 1. Because I do like the picture you drew here, so just kind of explain to me and to the other group the pictorial representation y'all did.
So the top picture is the bottle with the chord.
Okay.
That equals 315 grams. And the chord just by itself is x. And the bottle just by itself is x plus 300.
Okay.
So if you add the chord to the bottle, that would be 2x plus 300.
So you kind of use that picture to kind of visualize it and then lead that into how you did it algebraically?
Yeah.
Okay, that's good. So now, Canty, talk us through your, because I know you did verbal for number 1, so talk us through how you did that.
I'll do that.
That was my verbal.
Was that your verbal? Okay, so McKay, how did you do it verbally?
We thought of what was half of C, which is 7.5, and added it to 300. Or not added it to 307.5.
So when you say we thought of what was half of C, what do you mean?
Like half of 15.
Half of, okay, so half of 15, so how did you get that 15?
That's the fourth weight.
Was 15 the cork weight or was 7.5 the cork weight?
7.5.
Okay, so you did it right, so I just want to ask where did that 15, how you knew to divide that 15 by 2?
Mostly Gavin's idea, but he wasn't here.
Okay, so Gavin's idea, so what I think y'all did, I do remember Gavin talking about this, what I think they did is so they knew from their algebraic that 300 was the extra from the bottle, and so when you subtracted that away, the 2C had to be responsible for 15, so you kind of used, the algebraic and the verbal really went hand in hand, I think, for Gavin. So I think that's kind of how they did that representation. So let me ask when we move on to number 2, do we feel like I know Anthony said he liked the verbal version of number one better. This group over here, Linnea, Brayden, Allen, did y'all like doing the algebraic or the pictorial better to solve this problem?
Hey, Anthony, I'll take care of it. Leave that alone for now, bud.
Or
I
any,
mean, I thought it was easier to do the algebraic,
Oh,
just
it's easier
because
to
once
algebraic?
I see like a formula, I know what to do, so.
okay, Brayden, you kind of think the same thing, you like pictorial?
I thought the algebra was
Algebraic? Allen?
same.
What about you, okay, you like algebraic, verbal, pictorial, which one do you like best to solve this problem? Number one, yeah.
And I like that verbal.
Like the verbal? Okay, so well, the reason I'm asking is because oftentimes I know a lot of people do like the algebraic because it can sometimes be more efficient in solving problems, and I think we'll talk about that a little in number two. But with a problem like this, verbal can also work well just because you can logic your way through it. So there's, you know, obviously these aren't even the only ways to solve this problem, but you can, as long as you find a representation that works and you're comfortable with, roll with it. So let's go ahead and go to number two. I'm gonna have McKay talk about his number two, because I really like how he did both the table and the algebraic. So I'll have you talk about number two first.
Which one do you want me to talk about first?
Let's start with the tabular.
Alright. Tabular. That's a table. Right here, these are the days. The trips.
Okay.
This column's the trips.
Hey, Alan. Can you excuse
This
this? I was
one's
trying to
Roy.
avoid that.
Next. Joel.
Okay.
Joe.
So what did you see in this table when you made this? I see you blocked off the two 400s. What did that tell you?
Interest system.
Interest 16. So why? So when those two 400s were the same, we knew in this problem it was the prices were equal, right? They paid the same amount of money. So that was able to tell you that 16 was the answer. So now, but you did tell me that you like the algebraic a lot better than the table. So what did you do algebraically?
240 plus 10x equals 25x.
Okay. Then how did you solve from there?
Minus the 10x. Both
Okay.
sides. You get 240 equals 15x. Divide both those by 15. 16x.
Okay, so I like that. That's good. Now I wanna hop to this group real quick because I know y'all solved it algebraically the same way. We talked about a specific point I want to get. Is how did we know that we could do 10x plus 240 equals 25x? How did you know you could do that? Good, they both equaled 400, and y'all did the same thing. When you set up that system with those two equations, they both equaled 400, we knew that we could just equal them to each other and solve for x, right? So you did it the same way algebraically, so let's talk about how you did it. I think y'all did it verbally the other way, right? So just walk me through, how did y'all do that verbally?
We pretty much just guess and checked.
Guess and check? Okay, so now like I've told multiple groups, guess and check that's a valid method. Is it always the most efficient? No. No. Because there will be, so like this problem, it just happened to be a nice number, it was 16, but like, what if the answer to this was like 16.25? Do you think we would have guessed that easily?
That would have been a little more.
No, it would have been a little more difficult. So guess and check can work, but sometimes it might not be the most efficient. So let's think for a problem like this, what did we think was the most efficient way? Take a table of algebraically, guess and check. What do we think was the most efficient way to solve this problem?
2.
Yeah, number two.
I just think the table took too long, so
Mhm.
that's great.
Yeah, I mean, that's honestly a valid point. Sometimes tables just take a while. So the algebraic, because I know I'll watch you solve that algebraically in like literally maybe 15 seconds. So I do think algebraic is a great way to do this, but also for both 1 and 2, what we didn't talk about is we could have also done, I think graph was the only one that we didn't get to, and I think that number 2 would have been a great example of when to graph. But so that's another method we could use. But honestly, I love how y'all did all of these. So before we get to what the homework is, do we have any questions on how maybe the other group solved it, or any questions about this? I know we didn't get to number 3 because I wanted to focus on these two, because 3 is a little bit harder, but we'll talk about 3 at some point.
You said there was a way to graph
There is a way to graph it, so we can.
Do you want me to pull up Desmos?
real quick?
Yep.
So, 'cause we don't have time to all do it individually, but we can look at Desmos to graph this. So if you go into Desmos and you type in those two equations we had that were both equal to 400, so it it was 10x plus 240 equals 400. Bless you. And then 25x equals 400.
Bless you.
Y equals 25x. So we should, when we zoom this out, we should see both of these.
They're pretty close.
I think it was,
And they intersect.
so look where they intersect. They're gonna,
Sorry, I'm gonna try to zoom in more
You're good.
effectively.
so look, they're gonna intersect right at 400, which is what we were looking at, that specific instance of where they are the same at 400. And when we look at this point of intersection, which we're talking about, it's at 16. So if you go on Desmos and you graph those equations like that, you can find where those lines meet and cross, that will be our answer. So let's go ahead and go back to the slides, so we can look at homework before we get out of here.
You know we still have 10, right?
Oh, wait, we have 220, don't we?
Yeah.
Oh my
I was
goodness.
wondering. I
thought we were about to
was like,
get
are you rushing?
out. No, I thought, oh man, I thought we were getting out 210. Okay, so how about this? Let's as a class work on number